This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
Hello everyone. I would like to show my presentation about the power of DB2 for the OS database monitoring application. Brief algorithm of work self-developed DB2 resource monitoring, how to find performance bottleneck, first determine which of the DB2 subsystems consume more resource and start with it, build different charts along the statistic-account traces, search for heavy SQL queries, analyze this in statement cache and associate tables, analyze buffer pools statistic at dataset level, rules of thumb for statistic-account metrics, also generate daily report of buffer pools. It will be better to use some monitoring, even hand-developed, won't it? There are enough DB2 for ZOS monitoring application developed. For example, Amigamon Enterprise, Tivoli Portal, Broadcom Detector, BMC AMI Ops Monitor for DB2, Intel Magic, UBS Hiner, and others. They provided everything you need. And also you could be able to write your own monitoring for your needs based on available possibility from DB2. Amigamon and other enterprise DB2 data providers. I took advantage of this because I didn't have ability to use enterprise product mentioned above. Independently developed and self-programmed DB2 monitor application allow me to monitor all the main parameters of DB2 for ZOS, the operation of application with the database, and build the charts for buffer pools. In total, up to 297 charts. This application could be drawn. Allow with database monitoring. Also, I use two different self homegrown monitoring for the OS and table sources. To have a complete picture in a complex. But in this presentation, we focus on DB2 monitoring only. Brief, maybe please raise a hands who use some DB2 for ZOS monitoring with different charts, graphs. Okay, some people use, and I think it's helpful. Monitoring has two modules: backend, front-end. Every day, DB2 activated IFC-ID statistic account traces with specific IFC ID. All information write to the SMF log stream. Amigamon batch job every day, 3 times per day, proceed SMF log streams and load information into performance database, PDB. Backend application at night connected to the PDB and got some information from tables, aggregate them, and plus run to DB2 commands to get some additional information, and other different small application run every 5 minutes every time from this statement cache to fill information about this statement cache. All this information proceed by backend application and wrote to the DB2 archive database. Then in the next day, go at work DB2 administrators and have possibility to build chats. It's briefly algorithm how to work homegrown monitoring. The most percent of data proceed by Megamon and loaned in two tables. In this schema, I use statistic trace with save file utility. As a result, generate a VSM dataset. Also, accounting trace generate save file dataset. Then I load using load utility, load into performance database. Also, I use audit trace, but it's not performance case. Next, the technical literature on Megamon described the order in which chat should be analyzed. Statistic and system parameters to collect, then accounting, then detect some application. After that, we find SQLs connected with this application. Next level, looking and IO activity, then record trace. I try to find problems in the database monitoring application in approximately the same order. By analogy with above picture, from general to specific, I try to group the chats in DB2 Mon by blocks and display in the next slide. It's generally schema. First, step one, I use bench of chats, group of chats, statistic general, which include SQL DML chats, IDM pool chats, read list CPU times. Second, stat buffer also include 60 different chat, like general information, read write operation, sort merge. Buffer pool subgroup 1-3 buffer pool info alter also provide many information like current size of buffer pool, random get page, synchronous riot IO, random sequential operation, pages required, and others. Also, I use rules of thumb and all these charts have information which of subsystem DB2 subsystem I must do monitoring in the next step if in the LPAR installed more than one DB2. After when I choose subsystem ID, I go to the step 2 and build accounts chats. Also, this parameter like close, class 1, 2 elapsed time, class 3 synchronous I/O, local edge, get pages, buffer updates, synchronous read, 3 type of prefetch, and also rules of thumb. These all charts give me information, and I detected one, maybe 2, 3 application which consume more resource than others. Step 3, I build charts from DSN statement cache with different parameters like statistic synchronous read, execution times, statistic index B, and others. But not all SQLs I analyze in this statement cache. Only SQLs which connected to application in step 2. Maybe 1, 2, 3 application, and these SQLs I found in this statement cache and try to analyze. Also analyze access path from plant table and wrote heavy SQLs into history table. Step 4 give me information about how to use resources in table space level, index level, and give me to set right decision what I must to do to improve performance. This small application which run every 5 minutes and get information from DSN statement cache by SQL. This SQL I divide by 2, 3 conditions. First condition, it's generate last 6 minutes all SQL, which consume elapsed more than 20 seconds, and with prim aus user 1 maybe. Second, the same. Third, with additional parameters like program name. It's more connected with static SQLs. In some application, it could be used. After that, application test 1, these rows insert into history table. After that, run explain statement which fill plant table, and it's for further analytics by system DBA. In this slide, I would like to say about one of the main charts which I used to start in the statistic trace. I built different charts, but this chart is most important. Average synchronous read, input-output, random sequential by 1 seconds for all buffer pools. In this case, value 100 per day. Maybe it's high value because must to lower but it's important control this value from some period of time, and the formula is easy. Next slide. In this example, when I detect subsystem ID, I go to the step accounting trace and build different charts from accounting trace. For example, occurrences, and build charts from 2023 to 2024. The value is increased. Okay, the next parameter like get page also show me that in the same period of time buffer pool increased. Third charts I built and choose one application, SAP data plot. Build charts by parameter class to lapset. The value has been growing strongly since November and correlate with two previous charts. Maybe I still don't have completely information because in this case SAP data upload application maybe run from different hosts, maybe run from different user ID, and options like detail info allow me to build a list of application with additional information, IP, prim aus, and application name. And I built class 2 lapset time and more accuracy, more I know from host, from user ID who run this application and consume more resource. If application connect via TCP IP, then build IP prim aus client's application name. If application connected via CAF, then build location name prim aus and address space name. I continue to build different charts for SAP data plot application. In this case, synchronous read not increased. Not increased, and I built second accounting charts open. Open show me information that how often perform SQLs. In this case, actually increased value from 2023 October to January 2024. I ask SAP specialist and they answer me. I ask specialist about why increase this value, and they answer that they changed application and more often invoke SQLs, and it was the main reason why increase this value. And in this case, I didn't change in DB2 only monitoring. The next level, step 4, it's analyze DSN statement cache. When I know about statistic information, accounting information, I go to the descent statement cache and try to catch all SQLs connected with SAP data plot application, and different builds different charts with other with different parameters which exist in descent statement cache columns. For example, most popular parameter elapsed time. Second, after when I detected SQLs, I wrote some tables involved in these SQLs and tried to analyze at dataset level. First, build a list of objects, table space, index space. It's a list of this of different objects. But I find only this object from previous slide from descent statement cache. Maybe SQL number 306 use table HRP and in this slide I found a table space from this table and build charts by parameter number of get page and build charts from long period of time, maybe 1 month, 2 months, to have a complete picture how to change this parameter. If I need to know more detail, I set up to lower period of time. On the next slide, I set up a lower period of time and type archive. Maybe on the next slide. Yes, lower period of time, and in this case, build information every 1 minute. Every 1 minute per day. It's very precision, and I watch even in hours 60 different parameters, 60 different values in 1 hours. It's useful for me for deep analytics. How behavior table space or index space with buffer pools. Also, a good way of looking at the data is to focus on a few key indicators and apply a few simple rules of thumb, rules of rations, known rules of thumb for statistical accounting traces. In this application, not all rules of thumb have been developed, only several. In statistic trace, developed average SQL return row, average get page return, average get page per total DML. They provided first charts, SQL return row provide information how many rows return by SQLs. What's useful? Or maybe we have for all TP loads, this value could be lower than for data warehouse loads. In these charts, 30, on average 30 rows per day. The second chart about get page request per SQL statement. It's in two cases. The formula is easy, but useful, I think. About accounting statistic. In this slide, we talk about statistic rules of thumb. In this chat, about accounting rules of thumb. The number of get page requests per SQL statement. Get page request per SQL statement indicates the number of page that must accessed for each date row written on read by application. Normally, when SQL developed well and table have appropriate indexes, when date rows are read randomly with a unique key index, one page is read for each index level from 5 index level, and one page is read from the date. The lower value get page SQL ration could be caused by the use of table space scan as more usual. The use of non-matching index scan, maybe, I don't know, maybe stage 2 index scan, and the use of an index with low cardinality. It's main reason for high value. But I don't know, in this chart will to height, not 6, many height. I developed this formula. I use all buffer pools, sum of all buffer pools, and have possibility to use particular buffer pool 1, 2, 3, divide by these parameters. But my DB2 monitoring give me these values. It's too high for me. I don't know why, but I only control from time to time this value. Maybe in this formula I need to add others parameters. I don't know. The second rules of thumb, comparison of class 1 and class 2 times. We have 3 charts for easy A, B, C. What this charts use? What means? This ratio of class 1 and class 2 times indicate whether a potential problem lies in DB2. A difference of roughly 10% in these times is normal. If the class 2 elapsed time is less than half of the class 1 elapsed time, the problem is not with DB2. For example, A equals to class 1 elapsed, divide by 2. B charts equals to class 1 elapsed, multiply by 100 and divide by class 2 elapsed. And rules of thumb. If A elapsed more than class 2 elapsed, then Apple performance issue. Else, if B between 10 and 50, then DB2 performance issue. In the other case, suspension issue. What would we see? What will be C? A, B, and C. In this chart, usually suspension issue. But sometimes have have application issue. Second, comparison of class 2 elapsed and class 2 CPU times. The ratio of class 2 elapsed and class 2 CPU times indicate a potential problem with SQL. If difference between class 2 elapsed time and class 2 CPU times is between 10% and between 10 and 15%, the problem probably lies with SQL. Use an explain or SQL activity report. Also, like in previous chats, we have A, B, C. Also in the previous slide, we have A, B, C chats. Chats calculate like class 2 elapsed time, multiply by 100, divide by class 2 CPU not nested, without functions, stored procedures, and others. B calculated like class 2 CPU not nested, divided by class 2 elapsed. B. And rules of thumb, if A between 10 and 50 and B more than one half, then SQL issue. And if A more than 50 and B less than 0.5, in this case, DB2 performance suspension issue. What would you see in the chat C? Usually we have DB2 suspension issue, but sometimes zero. Zero, it's case when didn't suit for this formula. I don't know why, but sometimes this happen. Maybe everything okay. I don't know. Second rules of thumb, like calculate statement weight. This parameter this time taken for an SQL DML statement to complete depend on the speed of your processor. Typically for 100 MIPC CPU, a DML statement should complete in less than 1 milliseconds. We have formula select plus insert, update plus open, plus fetch multiply by x. X found in table where depend on mainframe value of MIPC. If a statement wait more than 1 millisecond, seconds, then use some monitoring to find cause like bad access path. But in this chat, we could be watched big value than 1 millisecond, but in this chat collect cumulative account statistic by application. Therefore, the value are much bigger than 1 millisecond. But it's still useful for analytics to build charts for long period of time and analyze behavior. The second rules of thumb, not a counted time. Not a counted time, it's time not with consumed by this DB2. Maybe others DB2 consume resource, maybe some address space consume more resources, and DB2 accounted trace also fix that value. This value calculate like class 2 elapsed time minus sum of CPU and nested, synchronous I/O, and log latch. As I said before, excessive time that is not recorded by DB2 indicate potential troubles with overload server. This time is not recorded by DB2, either in class 2 time or in class 3 suspension time. Second, rules of thumb, commit interval. It's in the class 3 suspensions, commit interval. Commit interval calculate like class 2 elapsed, divide by commit plus rollback if exist. Rollback, they also counted. Class 3 suspension indicate potential problems with locus excursions, long wait times for synchronous I/O, and long service task switch times. A value, if a value of between 1 to 5 is acceptable. If class 2 elapsed time is 1 second, and the commit is 1, the result is 1. It's acceptable. Higher value indicate problems with locus excursion, especially in batch application. In this chart, we watch that sometimes really this value more than 5, July 16, July 20, but after this value is just close to the normal value. The second chart slide, and after every night, DB2 application generate a report for statistic, accounting traces with some parameters from statistic, accounting traces, information about buffer pools, and this record include information about buffer pools, change for table space, index space, for current and previous 30 days period. Statistic account reports presented absolute and different values between 30 days period for some parameters, like in statistic trace, select, insert, in this case, select, insert, delete, open, fetch, DDF total time, request random, so different times from between 1 month. Previous parameter, current, previous period, current, absolute difference, percent of difference. I usually control percent difference. It's interesting for me. And maybe useful information about buffer pools. Today maybe didn't exist table, then table created with maybe by default buffer pool, maybe not default. In this case, marked like didn't exist, and yesterday and today exist. If buffer pool changed, this fixed old value buffer pool or current value. It's important, I think, for system DBA to know this changed, because it's have an influence of performance. And in the second charts show example from life of system DBA, like different examples which happen in work. For example, For one SQL, detect table space, DHL, and I built charts like type archive. It's mean for long period of time, maybe because this chart have many times they didn't show time. But it's maybe 1 month, 2 months period of time. And we detected this value from 120 millions get page per day we found in DB2 in the same way. What we did, we add some index, and after February 14, this value decreased. Also, when we built a chart from ZSQL, these charts from this statement cache, elapsed time show the same result. Elapsed time decreased. Another example of how during the study of the account trace chart, it was possible to notice an increase during a time period it takes to execute request per day for one of the transactions. Monitoring since 2022 to June 2024. Elapsed time from October 2023 increased. It means for business analytics, it was 20 second average time to proceed SQLs in this. But in this, it was around 50 seconds. It was a bad situation, and what we do, a compressive work was carried out. We redefinition of buffer pools parameters, like VP sequential parameters, dev. VP sequential parameters maybe increased buffer pools, reshuffling between table spaces, buffer pools, table space movement to universal table space partition by range, from partition range to partition by range, universal table space, and partition from segmented table space to partition by row related to this transaction, and of course creation of many optimal index. The result is obvious from 15,000 times to 7 times per day, and time elapsed time from each transaction was improved from 15 seconds to 50 seconds to 15 seconds. This chart show also improved value. Second example, one work has a claim about performance in transaction. We start to analyze different metrics by specify user ID in this statement cache. The number of lines that were checked for compliance with the search criteria. This is the job. It's stat row WB. Number of rows that are example for the STMT. This will grow since May 13 to June 18. And we use another application which simply collect information about count of rows. From this statement cache, we get information about SQL. From SQL, we watched a table name and build charts about KBLK tables and KBLK table and count of rows increased every time. We told the programmers to clean the table or archive the date. But I didn't show what happened. But after that, clients didn't call me. Maybe everything okay. Here is an example of get page consumption before and after query optimization in different DB2 subsystems. In the quarter or maybe half a year, we analysis of database objects from Statistic-account 199. And we detected that index, one of the index in buffer pool 23 consume get page, this index consume get page much more than others objects. We found all SQL queries which access path includes index and decide to it two, maybe one index. And after optimization was performed for one of the queries, when new index was added, we have seen a dramatic decrease in usage get page for current index and minimum usage for usage get page for new index. From this value to maybe very small value. It's very well. I know that 316 million get page is not too high value completely, but why not to increase to decrease this value? It's very well. From IFCAD 199, we built charts about all possibility column from these tables, like synchronous I/O average delay, max delay, synchronous I/O, useful parameter like changed page, because if value if changed page have a big value, it's bad. Maybe in SQL queries bad, or maybe you must to increase buffer pools. It's depend on situation. Built for DB2 Mono application have possibility to build statistic 199 for all buffer pools. In this charts show operation information. It's mean every minute fixed value. Every minutes. It's maybe charts too hard recognize, but if you zoom, it will be helpful. DBA sometimes monitor different parameters in the following order. Buffer pool for 3 months, detect buffer pools that consume much more resource than others, choose this buffer pools and build charts for each buffer pool individually. In this case, one should build charts with others, table spaces, indexes, which consume that resources. Then detect buffer pools that consume much more resources than others, choose table space, and build charts for each object individually, like in the previous charts I presented like when I built by table space from long period of time from short period of time. For more detailed statistic, it's possible to build charts down to the minutes for any buffer pools objects. In this slide, build charts by specific buffer pool 8. Every minute information show every minute. We I watch that sometimes this will increased change page, and if we fix that times and go to the DSS statement cache, we maybe catch some SQL queries and try to analyze why these queries consume more changed page virtual pool. Also build charts for specific table space from IDB OPR database. Also, sometimes value growth and go to the DSN statement cache. Also catch some SQL queries involved in connected with this big values. Of course, it's important to analyze numerous system parameters, mostly like statistic general, SQL DML, IDM pool, read list processing, CPU times, statistic buffer, read, write, sort, merge, etc. The following charts which I have detected in different subsystem ID. When I analyze these charts, the statements in global cache for specific subsystem ID was too low, and I correct in zparm value, and that allow to store more statements in global cache. Of course, it means more process to build access paths, more performance, and improve performance. But the growing troubles still needs for the solved in charts read not used, no storage. This one. No. From October 2023, it was near zero, but after that, this value increased. I don't know why, but I check from some period of time monitoring, and maybe something decide to do connected with this growing value. What may be interesting charts, number of data sets open, because it's in the business days, this value grow, in the weekends decreased. Hit ratio 19%. It's cumulative value, total value from all buffer pools. Maybe some buffer pools have 50%. It's too low. Some have 100%, and average value near 90%. second chats. Also, we have a bunch of different system parameters like get page, request sequential by all buffer pools. Get page request random for all buffer pools. Synchronous sequential also not connected with business days, maybe, I don't know. Synchronous read random total. Max work files concur used in total. Buffer update. In this chat, I focus on increased value from December 2024 in max work file concur used. This will start to grow, and I only build sometimes charts and analyze if this will increased. I start to think what to do, what I must do to decrease this value. Yes, it's also what I would like to say you. Maybe have any questions? Some questions? Generally, my two words about this monitoring. Before, I didn't have a complete picture. What's changed in database? What I must do? But this application helped me. And I in previous time I operate only Amegamon Amegamon reports, which have many parameters every day run by Statistic-account traces. It's boring for me. It's hard to analyze. But if you have some tools with which have possibility to build charts, maybe with AI. I don't know. It's cool, I think, and it's life of system DBA will be more easy. Yes, have questions? Slide 9, okay. Oh, it's a slide 9. Так. Yes. Yes. Slide 10, okay, yes. Three conditional, yes. Maybe backward. Maybe we'll start presentation. Yeah. Okay. I create this SQL by my own. I decide in one subsystem. Maybe this is OLTP, online transaction processing database. I decide that some address space works slowly, and I extract information about prim auth that address space, and show and ask people who work with this transaction normal time. They said if response 10 seconds or 15 seconds, it's okay. If more than 20 seconds is bad, okay, I write this information and build SQL based on this. Because so for each subsystem, DB2 subsystem, I create own condition. Yes, I got this information from system, not from user. They didn't know about that, of course. And I extract this information and add into column program name. Yes, yes. And but generally, I if I don't know about some conditions, I set up default value like current timestamp minus 6 minutes and start elapsed maybe 10 seconds. But if catch many SQLs or maybe two a little SQLs, I adjust these parameters from each DB2. Thanks so much. Maybe other questions? Okay, thank you for audience who listens me, and my presentation is ended.